The recording, yeah. Okay, so literally, yes, we can make that root as the static global variable, and we can we can just make that receiving the element or the last element of the array. As we use the array list, so we have to use the get command, right? And then we have to set up a null to that index element in the array, as we understand, right? And then we're gonna use the preorder to go through the root, because for each root in the tree, we will be operating with leaves. We'll be filling leaves with elements from the array, which automatically means that we have to recursively go through all of the elements which are implemented. I mean, to go through all of the roots which are implemented in the tree. So now, so we will have the pre-order function. Well, here yesterday I wrote kind of meta code without the syntaxes check, as you understand. But we can fulfill that with the syntaxes. So that will be such one, as well as here for the entire function which will be used recursively, we have to use prefixes and a returnable data type, as you understand. Yeah. Another thing, comparison of the texts. Since we use the strings, so we cannot compare them just by equal sign, we have to use a function called equal. Equals, yeah. So, and same should be done for displays. So equals, yeah. Literally, that's the way how we compare. So go to the array, and if element is not null, then we compare the roots left leaf letters with what we get in the array. And if we have, then we cache that element, and we replace that in the array as null. And the same will be done for the right leaf. And then what is going on? We can do the same if we have the right and left leaf. So if we have a left leaf not equal to null, in other words, it exists, there is such instance, then we recursively go through that leaf as the root. So that will become a root for the preorder function. And again, afterwards, we are working in the same manner with the right leaf. So again, we run recursively the function for which the right leaf will become the root element. So that's the way how I would do that. And actually, guys, if you will implement this, the only thing we'll be missing is naming the paths and literally saving so-called a dictionary, right? Which letter has which binary code. But you guys did that exactly in the same in that manner, I suppose, right? Because how else? Yeah. So that's the thing. Yeah. So what will be the next one? The next one, you can always go through the array, through the tree recursively, and you can collect literally you can collect literally uh, the dictionary values. How you can actually even fulfill the full encode. So what we can do, we can literally add the path from the root to the leaf using texts. For example, initially, we will say that initially we don't have the text that characterizes the path till this element, till the root. Because when we give the main root, the path was not yet started. We allocate it on the top of the tree. Here, what we can do, we can we can have the path. Oh no, we have to use the comma. Yeah. So we can have the path. And how do we fulfill that, guys? Well, we just give a path here. How? It will be path. What's next? Append, right? Oops. Wait a bit. If we have in implementation append, no. Add. Okay. What was the adding function? Oh, do we have the concat? Concat. Concat, and then we can have a 0 because we can literally name the left path as the 0. Well, again, that comes from materials because we didn't just imagine that it's the 0. We have it selected here. The left is 0, the right is 1. So for the right one, it will be a 1. Okay, looks great, but the question is, okay, we have it, but at which point will we say that we literally are having the full pass for storing this, for literally getting those paths? Do we have to do this here, or we will have to make another recursive calls? How do you think? Maybe another recursive calls, right? Because we have to have the tree constructed, right? And that would be correct. So literally we have to do this, but in another function. So let's make another function which will be called a pre-order path. Well, at the beginning here will be the same. Literally, I will copy these functions, and I will erase this text from the previous one we had, like this, because we split functionality into parts. So we have pre-order path and we have pre-order path, right? So, and here we'll be having pre-order path like this one. So what is missing? We're not constructing the tree. We just go through that. Okay. So the question is, what we're gonna do next? Okay, we have the pre-order going through, right? Okay, what is the reason, or what is the data, or what is the information by which you can say that we located in the end and leaf? How we can know that? That's the root is the leaf, and it doesn't have any other connections. The left and the right are equal to null, right? Both of them. So what we are doing? Okay, so if, and here we'll have two conditions, or we can just write that in the one condition. So if root left is equal to root right is equal to null. Okay, if we have strict definition here, then we wouldn't be able to make this one. But why it shows me that inversion would be correct? No, that wouldn't be correct. Okay, so let's do like that. We have root left equal to null, and root right equal to null. Then that means the current root is the leaf. Makes sense, right? And which means that inside the dictionary, we can create a dictionary if we like. We can add the path for the symbol. Well, probably, guys, you can create. By the way, you can create a dictionary if you like, or you can create the array of the class. No big difference at all. So I'm just showing you the simplest way. So, for example, we will have a dictionary element. Dictionary element. Okay, it could be the class, and here we would have um, primary the letter, and we will have the path like this one. Okay, and you know you can always create the constructor which receives both of these elements. And here we will be just you know assigning them in a such way, and then we can just make an array of such elements actually. So so again, here, well, for example, here we can create the array of dictionary elements which we created. Let's call it array D, and here we will be using dictionary elements, and each time we will be having such case when left and right leaves nulls, then we'll be adding an element very easily. So we'll be given letters from this root plus we'll be adding the path which was constructed for this leaf. Literally, in that way, you can create a dictionary. And what's then is missing, guys? Nextly, we have to literally go to the original text, and we have to be looking for letters in the original text. Sorry, from the original text, we have to look for letters in dictionary, and that's it. And then we have to just make replacements, and that's it. Since I don't have the full code here because I was just showing you the concept, there's no point to run this. But literally, how after this preorder and preorder path, I would be replacing text. So let's suppose I have some text because I didn't have it. That would be equal, for example, with some, I don't know, maybe ABC, right? No big deal. So we would have to go through the through it, for example, in a such way, or text one, then plus, for example, in a such way, and then you can organize the searching. So so let's suppose it would be using another, let's say another the nested loop. We would have a dictionary. We would get in the size. So we would be going to all of the indexes, and for example, we could compare if array D okay, what get element point letter equals to, and then we can receive the letter, the character from the original text. I read text char at, and we mention the symbol. So if that's equal, If that's equal, then we found out. And then, for example, we can make a printout, if you like, of the code for that symbol. So again, from the array view, we'll be getting element of j point path, which is the text. And you literally will receive all of those symbols, all of those binary codes into a row. Okay, it will be printed out, but if you like, you can even save that in some textual variable. There's no difference how you will do that because you know options, well, a lot of options how to implement this. But it's one of ways how you could do that. From my perspective, I described the left part for most of your group at this point. So the question for those who are still working on the Huffman codes, is this idea clear for you guys? Were you able to follow up this? Barely, right? Okay. So which part is missing? Which part is not really understandable? Okay. Do we understand that we have to construct the tree from the array of roots? Yes, no? So is it understandable what's going on in this function? So you guys, you didn't open the records, right? Because I was asking you to take notes. Okay, so you'd like to make it together, right? Yeah. Okay. Okay, makes sense. But unfortunately, we have to finish with this others on this. So, so how's the progress?
No chyba nie jak się nastawić pakiet Raiden taki. Po prostu podcast Raiden.
Ah, yes, we had some problem yesterday.
Swojego aż
Yes. No, if I'm not mistaken, the problem was the text, right? So, and the string was equal to blue, isn't it?
Типа przekaz Raiden.
Okay. Index, and then you have the L index.
Jest jego podcast. Wiedział, Sarò per caso sì, ma capa da quelli
In different steps. Yes, the check. That's what I would do. That would be the first step of mine at least. Okay, Lorena, so what do we have?
something.
Because yesterday we did all the things before what I showed you today, right?
Yeah,
Uh-huh.
I believe so.
You believe so. Okay, that's great.
I'm kind of lost what to do now because I've done like what I could.
Okay, so you mixed up two functions. So here we have okay. It's a bit different, right? Because you see, we can build a function and you do that in the main. Isn't it? Yeah, so that's the main function. But this is the content of the pre-order function. Take a look at this here, right? You see, that's the function. Okay, I can who is this? So let's make corrections, right? Let's have this. All right, so the first tool, this is great, this is cool, but what is necessary? So here we have the main functions end, right? Let's put that here, right? Let it be so. So why do I have a preorder and a preorder class? Because we have to start with something. So this function is not going to be recursive. That's the beginning. So I will be doing. So I was doing the following. So I created a static void. Then it was the preorder, which will be run only once. Here we have. I suppose you have the same data types, right? So we have the root. Okay, that's great. And we have another static function, which should be run recursively. I sometimes put just for differences the underline to make it totally different. Yeah. So after that, here we can put the end of that function, and we can initiate that right there, given the like this. So here we don't have the problem anymore. And here, why do we have it? Because we don't have the access to the array. So let's go up and let's take that array and let's put that available for every function. Like here, right? But since we have the static functions, which work with class, right? We have to make the array static as well, like this one. Next, you see, problems disappear right there. So, the next thing, you mixed up another thing. So, what do we have here? So, for a root, if we have the element, then we check if that fits for a leaf, right? If that fits for the leaf, then we take that and we erase that from the array. Does it make sense? Okay. So here is for the right. First to the left, then right. After that, what we do? After that, we do the same, but only for the left. If we use so far. And for the right, if that exists so far. And literally by that, after you run this one, you will consult the tree. The tree will be added as an extent to this loop, right? It's understandable. Okay, and then you have to construct values. So it means you will have almost the same code. Almost the same. It's easy just to copy. Here we will add the path because that's the reason for this function. Like this one. Surely we're using this function to run it here and to run it here. But since we are only going through the tree without constructing it, we erase it. Oh, and by the way, we have to move this part to be run after we went to the array. So yeah, they should be fixed in such way. That's understandable, right? And here we have only going through the tree without any modification, because you already used all of those array roots. So The only thing missing here is a construction of the path. So initially you will have a zero path because you are just located in one point. To have the path, you have to go from one node to another. It's understandable, right? So, which means that initially we don't have the path. Then here we wouldn't have the path as well because that's by that we initiate the recursive function. And here we can already use that. Surely here what we do, we say that we will have a variable argument. As well as we will have that for the recursive function, like this. So each time you will be going to the left or to the right leaf, you are moving, right? So you are going by some of the paths, right? When we go on the left, we say we are given a 0 for that, right? When we go on the right, then we say we give a 1. So we have to give here a 0, and we have to give when we go to the right side 1. Yes, exactly. And in the same time, as you understand, we operate with left leg, we operate with the right leg, but what if there is nowhere to go? Then we are on the final leg, right? So, which means that we have to check that. And how we can check that? Only when on the left side and the right side we have nothing. So, those are two conditions. So on the left, we have nothing, so it's equal to null, right? And at the same time, on the right side, we have null. So we have just empty spaces, right? Kind of. Okay, which means that here you would need to fulfill the array with the path, which is the currently created from the top root to this leaf, right? So for that purpose, you will need to have. Oh, okay, you already have dictionary element, right? Yeah. So here, well, that what's the function? You know, the path again is created by the path, so that will be the string. And you have to have such variables here because you will have to use them. Here we will have such thing, and we have to make them public. Yes. So we could access them from whatever please letters. Actually, there's only one letter, but okay, let's call that letters. Okay, and then we will have the path itself, like this one. Okay, so what's the next? The next thing, you are making this array, dictionary element, like this one. Then it will be a dictionary row, just whatever other name the array, right? What's then? Next, we have to add the element because once it's the final leaf, then we just added that. Create a new element, new dictionary element, and here we will be given letters and the path, like this one. So which means that after this function, you will have array D filled, right, with all those symbol and the code. And the next thing you have to do right here is just going through the original text, which you probably have somewhere on the top. No, you don't have it. You have all the appearances written by the hand, right? Okay, so which means that you have to have the text that contains these symbols with such appearances. Okay, Well, what you can do, you can take even the text from the example from the presentation example, and you can go through that in the same manner as well. I will show you on the screen. In the same manner as we have here. Hoffman codes. On the bottom, yeah, take maybe this one. I'm not really sure about but string, variable, people, and then the text. No, you can do that inside because you analyze this in the main function. Я так понимаю, вы понимаете, да? У вас то же самое. Да. Угу. Хорошо. Ну, я надеюсь, скриншоты все же делаете, то время от времени, да? Ну хорошо. Хорошо, так. Никита, как у нас тут дела? Так, хотелось бы лучше. Окей. Я смотрю, скриншоты у вас... нет, это получается. Ну хорошо, что мы успели с вами сделать вообще по Hoffman кодам? Ну, может быть, покажете проект, если там есть что-нибудь. Ничего, ну, фейлер получается. Хорошо, а что у вас не получилось? Ну, вот на каком этапе эта загрузка пошла? Ну да. Не, ну я так полагаю, что сразу какой-то интерес все же.
Зачем так? Я не важно ничего.
Ну, многие вот тоже поступают на эти, но они не понимают тоже, что там математику нужно изучать и все остальное, особенно на бакалаврах.
Математика.
Да? Ну, уже хорошо. Ну, допустим, у нас, например, в Европейском университете, там 5 разных математик. Ну, потому что действительно надо знать, применимо надо знать, но и все остальное тоже. И зайти можно в очень разные направления пути. Так, ну ладно. Начнем с первого. Ну вот мы понимаем, что тут у нас, в общем-то, процентное появление силового текста, да? Это мы можем как-то посчитать?
Ну, получается, мы можем взять, выйти
Ну, хорошо, смотрите, вот, допустим, текст какой-нибудь есть. Вы можете с него вот сделать массив с символами, которые в нем присутствуют, и, ну, процентуально сколько символов в этом тексте. Это то, вот, что в первый этап здесь. Ну, как бы, можете сделать, можете.
тяжело.
Тяжело. Окей. Хорошо. Вы можете, вот, скажем, из текста составить массив, просто учитывая буквы, которые в нем есть.
Ну, удобно, да.
Ну, на самом деле, сейчас сказать, вы просто идете по тексту, и вы смотрите на массив. Ну, вы можете даже переменную сделать из файл, который будет равно, допустим, false. Если массиву есть что-то, когда вы проходите по массиву, сравниваете каждый элемент с текущим символом в тексте, если находите, у вас is found становится true, и, соответственно, после этого прохода по массиву, если он вообще был, вы проверяете is found равен false, тогда вы заносите элемент в массив. В общем-то, таким образом вы можете такое составить. Потом вы просто пройдете по этому массиву и для каждого символа, который у вас там занесен, вы можете найти, сколько таких символов в тексте. Просто у вас получается nested loop, внешний и внутренний цикл. Внешний цикл у вас по массиву идет, а внутренний идет по тексту. И для каждого символа массива вы ищете, сколько таких символов в тексте. И тем самым вы составляете вот такой вот массивчик, где у вас, ну, может быть, два массива, соответственно, как вы там хотите его составить, через класс или там через dictionary, ну, как угодно можно делать. Ну, и вот вы получаете первый такой этап. А потом вот абсолютно то же самое, что я вот рассказывал вчера, где мы циклично проходим по массиву и объединяем элементы. Последний с последним. На каждом этапе мы сортируем их перед объединением. Просто вы не стесняйтесь задавать вопросы, потому что тем более, когда я тут, ладно, когда онлайн у нас там сложно, наверное, что-то спросить или оперативно выяснить, но тут
Сейчас буду разбираться.
Хорошо. Разбирайтесь. По себе подуматься. Ну, у нас вот засада, я так чувствую, потому что это не особо даже в онлайне видел, чтобы было подключено. Ну так, чуть-чуть было в какой-то момент. А записи не смотрели еще, да? Не смотрели. Записи не видели. Но вообще, конечно, нажимаем на presentation, ссылочку, и все вы можете смотреть. Но то же самое и с остальными курсами. Там такая же система. Надо как-то делать эти ассайменты, записывать их, потому что даже то, что было на прошлой неделе, нужно было сдавать. Хорошо, ладно. У нас, как помните, у нас, как мы это делали цвет, у нас еще ползень белч остается. Это у нас второй алгоритм компрессии, да? У нас есть еще был третий. Но как бы я не знаю, если хотите, вы можете реверс рассматривать с остальными коллегами. Потому что мы сейчас будем реверс рассматривать регулярные выражения. Она новая для вас, но на самом деле это такая довольно общая тема для IT.
Можно поговорить, я хочу сделать немножко.
Да, конечно. Я думаю, можно, да. Да, можно пришлите мне.
Да.
Или можно даже сразу.
Я сделаю отдельно, а потом...
Да, хорошо.
Да. Ar sutinkat su Danai, kad nufotografosiu ne prieštarauji? Nelabai norėtum, gerai, mes tavęs neįveisim. Jeigu tu nelabai nori. Jūs neprieštaraujat?
Aš tau nepatokėjau.
Tai čia, žinau, nežinau, konkursai.
Ну, начинается стеснение.
Да. Tik skardinę tą
Kultūrų kepurė.
Ну, это не надо.
Nu, tavęs neįtrauktų, kad reikia akademiškai. O dabar galite atsistot, vat su dėstytoju kažkaip, kad vieną tą nuotrauką padaryt su dėstytoju. Gerai?
Может быть, на фоне даже телевизора, потому
А
что...
может быть, на фоне телевизора, чтобы вы... Да. Gerai?
Materialis pabėga, kaip žinodamas, kaip vyksta.
Gerai, fotografuoju. Ir dar vieną. Gerai. Ir iš jo palaukit, aš telefoną.
Да, сейчас.
Iš dėstytojo, gerai? Dar vieną.
Aš kaip žiūrovas, aš tik prieš kartą savo klasės
Tai aš neimsiu, gerai? Atsistokit už vaikino, kad jeigu nenorit kojų, kad matytųsi, ar nieko tokio. Не понимаешь?
galėjai grįžti.
Стойте за парнем, если не хотите, чтобы я ваши ноги сняла. Девушке говорю. Ничего? Окей. Шипсомец. Чиз. Еще одну.
Да, очень хорошо. Да, хорошо, спасибо. Возвращаемся к тому. Значит, мы сейчас будем Элекс смотреть. Немножко другая тема, потому что нам как-то надо дальше двигаться тоже. Я даже не знаю, как мы сделаем. Ну, может быть, даже просто продолжать. Попробуем отдельно все же тогда все сделать. Okay, guys, so since you're kind of bored, you're bored here, right? So let's maybe take a look things on Rex, right? And you try to make some maybe solutions on the Rex. You know, it's not complicated at all. There are just a couple of rules we have to remember. Right. So things related to regex are quite simple. The first of all, it comes from the regular expressions. Literally, it's something similar to the SQL language. You know SQL, right? Okay, so that will be quite easy. So it has specific rules, like in SQL. Especially, you can imagine that it's more like operation like, which is the regex actually. Again, but pretty limited. So there are kind of letters and combinations of them, which means something. Mostly they mean appearance of something. For example, we have a digit, that means /d, lowercase d. What does it mean? It means, okay, an appearance of digit. If we would like to have none and that thing, then we use the uppercase. So if lowercase is digit, then uppercase is non-digit. If lowercase is symbol or textual symbol, then uppercase is non-textual symbol, like the opposite. Makes sense, right? Okay, yeah. Literally, there is even the point which means any character, like in the SQLite command, right? You can have percentage, which means whatever amount of whatever symbols. You can even have the underline, which means whatever but one symbol, right? You know that, isn't it? The like comment in SQL. So here you can imagine that the point is something like the underline for the like comment in SQL. There are even ways for combinations. For example, the slash means exact meaning, like /d, /b, and so on and so on. The grouping using the square brackets means one of something. The range means one of the range. For example, A to Z, which means one symbol in the range of from lowercase a to lowercase z. The range appears in the character map, which is implemented in every operating system. So we have even the union. The union is just a merging together. And for example, we can merge several regions, or we can match several groups and so on and so on. For example, here, this union means that we would be having two symbols. One comes from the region from A to E, and another comes from I to U. Makes sense, right? And here, for example, this one means an intersection, which is using and signs. So, which means that we can have several ranges, or like here we have kind of selections. Which well this type of union, when we have one and another, means we are having one or another. Oh, sorry, about this one, it means we have a letter from this region or from this region. So here we have A or E or I or O or U. Yeah. So that's how it could happen. Related to modifications of that. In the same time, we have quantificators. What is the quantificator? Literally amount of appearances. So we could have, for example, the question mark, which means once or not at all. We have multiplication sign, which means 0 times of appearance or more times than 0. We have plus, which means once or more. We can have exact amount of them, or at least, or specific range. For example, if here would be 2 and here would be 5, it would be that the x is about to appear from 2 times to 5 times. Makes sense, right? At least so far. Let's maybe take a look how they work in the combined way. For example, brackets and ABC, which means that we're expecting for a symbol which is A or B or C. Makes sense, right? No? Who said no? Ну ладно. Хорошо. Okay, so slash D, what was the slash D? Digit, right? And plus, so at least once. So which means that we have the digit which appears at least once. So it could be 1 digit, 2 digits, 3 digits, and so on and so on. So literally that's the number, isn't it? The positive number. Okay, the next thing, we have a 0, then we have small x or big X, and then we have at least once appearance of what is placed into brackets. But what is in the brackets? From 1 to 9, or from lowercase a to lowercase f, or from uppercase a to uppercase f. So one of these 3 regions is about to appear. And since the quantifier is related to the brackets, it means a symbol from these regions can appear multiple times, well, at least once, because it's the plus. And it doesn't mean that it has to be the same symbol. It could be several times from these ranges, which means it's not the same, but it could be whatever symbols from these regions. Makes sense, right? And when we merge them together, what we receive? Well, that's the way how we write hexadecimals, isn't it? Okay, how would you describe this one? Yes, and how many symbols do we expect to have? No quantifiers, then it means 1. Since there are no quantifiers, then it means only 1 of such. So it means we will have one symbol, but that symbol can be from original from A to F or from the region from N to S. Makes sense, right? Is it making sense? Okay. So in the Java, we have the following examples. If you like, you can program them. If you don't like, you can avoid that. So literally, we can use the matcher and the pattern. So the pattern assumes to have the regex expression, and the matcher has the text, which will be analyzed using the pattern. Okay, cool. We know the classes, but how it works. What comments we're about to use? We can use spatial functions to go through the matches. For example, the simplest case would be the following. Well, we will have to have regex functionalities because that's saved in the specific library. And we can have the pattern itself. Then we have the text, which is going to be analyzed. And if we have some matches, so something's found out by the regex expression, then we will automatically take the first match, and we will show where it starts, where it ends, and what has been found out by that match. So what does it mean? A star B. Well, A, B are letters, but star, according to our writing form, means 0 times what is on the left or more times than 0. So according to the code, that means none of A's or whatever amount of A's, and then that follows by B. B follows that. Makes sense, right? So here we have whatever amount of A's, and after that we have one letter B. So that's why we found a match. Make sense? Okay, let's take a look on another example. A star B, so the same. So the first match goes for this B. Why? Because there could be 0 A's or whatever amount of A's, and then B. So that's this letter. Would you agree? And that's the first match, because here we don't have the loop to go through all of them. Okay, the next thing, we can have while to go through all of those matches. Well, how? Well, we have the same pattern, and we have such text. Okay, while we're finding something, so each time it will be the next match from this text found out. So we have 0 to AB. Does it fit? Yes, it fits. So here AAB. Well, the same, 2 A's and then B. Then one symbol B, because before that none of A's and then B. Well, that's how that works. Sometimes we need to have this control symbol, which would mean for example a digit, right? But how do you write that symbol, that slash, the control slash in the text? We mentioned that 2 times, right? To have that symbol. So that's why to have such controlling symbols, you will have to use slash twice. Okay. Sometimes you would like to have, for example, a dot, right? Which will be a dot, not whatever symbol, but a dot. For that purpose, you can use a double slash. So you are saying that's the symbol. Because what do we have by the slash and then symbol? We use that as exact symbol, right? Here you can use the dot for that. Well, here we have a couple of solutions, which I would like you guys to try on computers. So you can take the code of the Java and you can try to implement the following tasks. Overlay there, if I'm not mistaken, some 15 of such. Yeah, 15 tasks. And by the way, guys, you can try to use it in a way that you're not kind of looking for a solution. You can take a look on the result, and you can literally program this result as the pattern. So please, guys, please try all of these options, if you don't mind. Ну, хотя бы можно подключиться тогда к сессии и послушать лекции, если хочется домой. Okay, well, so how's the progress?
I don't know where to start off with.
But we have almost everything, right?
Almost everything.
Okay, let's see what is missing.
So I need, like you said, a string, but I couldn't
You
believe.
didn't do that yet.
No, I didn't understand. I didn't want to interrupt you explaining that to others.
Yeah, for example, you can take that text which you have
So this
here.
one.
I really hope that fits those things. But you know, it doesn't matter. Just take the text.
This
Yeah.
one.
So that's the value, but you have to have name or variable. Original text, for example,
So
only text.
just that.
Something else that is lowercase.
So let's say
Regularly with uppercase we start process. Original text.
no. Text. Yes. Right. This is all.
Then equal and then the text in quotes, between quotes. And quotes.
Okay, so that the string original text.
Yes.
Next bit would be
Oh, okay. It's not much, right? Yeah. So after the pre-order path.
yeah.
No, after that. Okay, I will show you on the screen. Maybe you can. Yeah. Guys, you understood what we're trying, right? Okay. Yeah. So yeah. So what do we have? The text. We go to the text symbol by symbol. Here we go to the array. Um, yeah, dictionary, and we compare. Because we have to find out the element with such text.
So that's string original text. Should I just paste it here? Shouldn't it be better? The string text.
How can you paste?
Paste.
How can you paste? You can select the text.
String original text equals. So this is basically what I did here.
Yes.
So I'll stick
Doesn't matter where you put
Yeah.
that. Doesn't matter.
It's in the same. Yeah. What's that?
Can you put that back?
Uh,
Because you took that down and you didn't put it anywhere.
there's some.
Still there. Okay. Yes. Good.
Move it. 0.
No, I will put that in the chat. That will be easier. You have letters instead of letters.
Multiple.
Mhm.
So,
Yeah, so let's run it. Let's see what will happen. Okay, you have the problem left is no letters. Cannot read that. Where? It's located in the main line 70. 70. It's
oh, my.
no, it's there. It's in the pre-order. So let's go to this one. Left. Root is not known, then we go to left. Because left is known. Cannot read letters when left is known. Letters. So we cannot compare. Okay. Maybe here we have the strict mode. Yes, maybe we have the strict mode of the language because I didn't check it yet actually. So in this case, please add additional if we have something on the left.
So
Before this if.
before this if. So
If root left is not equal to null, or left is not null. Like here, exclamation sign, null.
No.
Yeah, and then that will be enough. That's what mentions the same. The same is here for the one. Yeah. No. After this. Yeah, enter. Right. And let's run it now. Yes. So we have it. The only thing we don't have any printouts, right? Okay. So You know what? It's a bit strange. Um, um, that has to be more. Because the only reason when it can be removed, when it's the final leaf,
Because
then it will not be removed.
This is
Then it will be removed. Mm-hmm.
Unless maybe not reading anything after the null, 0 point, and that doesn't read anything.
No. Null means the empty space. I'm just. Oh. Let me check.
Yeah.
Yes. Exactly. Because you know, I'm kind of sitting and thinking, well, it's not gonna happen. Okay, let's run it. I suppose we could even take this out.
Yeah, because probably. Huh?
The final leaf. Okay. Um, let's say wait. Then if that's not move, we're going to the left. If it's not move, then we're going to the right. Uh-huh. And then we go here, right? So, in this case, let's do the following. Let's print out the letter of the root, all letters. So print ln, then the root, point letters plus empty space like this. So how many elements do we have? We see A, D, E, D, E, D, E, which means that not all of them are being saved. Okay, what we can do next? Let's analyze this part. So we have areas of the root. Okay, we're going to do that way. If element is not known, something like that. And how do we know that we have elements in the array? Um, uh, so we have summation of the letters. What the hell is this? What the hell is this?
Should be I.
It should be I. Okay, it's not critical that we know it's not correct. Right?
Yeah, wrote it down. From the example you showed us, and I thought it was something weird. It looked weird, but I didn't think much about it.
Mm-hmm.
Yeah. It was in the example, so I just wrote it down. Then it should be yeah.
Mm-hmm. 6x. The root. Okay. You know, things kind of look correctly.
We try running it, and then try to see.
In theory, all these printouts. Mhm. Oh wait, where did I see that printout? Ah, yes. Okay, not here, but oh, where did I see that? Ah, yes, yes, yes. Okay, and do we have everything or anything after that? So if we have after this one the printout of the array, what will it give us? Addresses maybe. Uh-huh. So which means that one element is still not used. Good question one, right? Yes, good question one. So what do we have to expect? Um, VCA, right? Is not used. VCA is not used. Okay, but there are three symbols. Three symbols. Size is totally down. Okay, let's get on. Let's go to the file. Now let's print out. Um, right. One. Yeah. Here. CA. So CA, all of others are nodes. CA. Okay, which means that if there's a BCA, then I suppose there should be BC somewhere. Okay, you know what? We can check it before the pre-order. What do we have in this file?
CBC.
And Novella. Because of this. Because of this one. So, please, let's do that. Before getting that. So, wait a bit. Where will be disabled display help? Yes. So, let's see. We have CA, we have DA, we have BCA. So, literally the right of BCA, it should be CA. We can even print out the left and the right leaves data. So, okay, where do we have the print out? Yes, here. We can add. Well, you can write that. You can write that. You can write after the space the left leaf letters and the right leaf letters. Space.
Space. Left.
No, the actual space. Because that's the printout. Quotes. A space quotes. Quotes.
Okay.
Space inside. Yeah.
Okay. And quotes.
No, go on the right one position. Plus. Error. Get J. Point left.
And another R. And
Point back.
point there.
J. In brackets.
Okay.
Point left. Left. Point brackets. Yes. And the same for the right point as well. This one.
I just think that is.
No. Just continue right. But you can just copy this on the right and change right or left to the right.
Yeah. Just copy this. Yes.
Space.
Yeah.
And
plus. And right.
Like put the space here.
Yeah.
Okay, let's. Sorry, plus. Let's go. CA, DE has DE, BCA has BCA, and this has BCA, then DE. All is pretty logical. Yeah, all is pretty logical. The only something is missing with the logics of our Pre-order. Okay, let's go to the pre-order code then.
Можно ли его вопрос?
Да, конечно.
Нам нужно считать, ну, как вы сказали, ну, там, вот этот вот, или как бы A, B, C, D, E, эти буквы.
Ну,
И
эти буквы должны быть, у них должно быть такое количество, ну, появлений, которые у нас с вами есть. Записано. Мне кажется, это тот пример. Я могу ошибаться. На самом деле оно должно сработать.
я теперь думаю, как, ну, если чтобы вот это видите или нет.
Ну, рассказывайте.
Ну, как вот есть вот этот текст.
Да, хорошо.
Я тут не записал, но его не считывает.
Окей, смотрите, ну, во-первых, хорошо, вы его записали. Если это какой-то кастомный текст, не такой, как у нас в примере, то нам надо посчитать, ну, во-первых, найти какие-нибудь символы, и потом для каждого символа рассчитать процент его применения этого символа в тексте. Да, кажется, где-то все верно. На сегодня, то тут мы вроде тоже обходим массивы, конечно, well, I mean, looks like correct one, but something's missing. Because Eric is full play. Get one, but it should be get I, not one.
Yeah, I noticed it.
Yeah. That's one. Okay, we will do some print now. So let's go on the top. A bit more. So literally, what is going on here? Looks like we can actually check everything, right? So maybe we can click and maybe it will show us contextual menu. Remove with state. I don't know, find goals. Oh, maybe you can convert character to string. Maybe we can put point to string maybe. Capital X and then point to string. Oh, okay, maybe we could convert that character to the string so we could compare them. Okay, no matter because literally what we can do here the same get no char at like character at. We can use this one, right? Equal to this one. Yeah. Okay, yes. Here it had to be J because
Oh, yes.
we have to do original text is I, and
Should be I as well.
no,
No.
letters 0.
So it's good.
Yeah. Because there's only one symbol, so index 0.
Yeah, okay, I understand. So all in all.
Can you compare that number to what we have in the presentation?
What? Yeah. This one. Right?
In the yellow.
Yeah, it doesn't. I don't think it's right. It's 111.
Okay, so it means we have different appearances. Yeah, we have different appearances. Yeah. But don't worry, other guys have the same thing. So if you would like to have it for the customized text, so you will need to analyze the customized text. But all the rest looks great at this moment.
I had a bit because like one
Yeah.
use the I as one like I, so
Yeah. You would find a mistake, and then you will have the results.
Yeah. Okay, so it's done.
Yeah, that's done. You can upload that. Ну, я думаю, вы видели, это что делает, да? В общем-то, точно таким образом можно поступить. Так, Никита, что вы пытаетесь сделать? Хорошо, я вас не забыл, тогда будут вопросы задавать. Мы пытаемся понять, почему. Знаешь, как на деревне, да? Ну, как
Я даже не знаю, какое слово. Я с Java вообще. Очень сложно, поэтому.
Ну, на самом деле, там почти все работает так же, как и в C++. Вообще, Java это настолько было сделано в свое время. Единственное, что там виртуальная машина запускает исходно, они компилируются. Ну, а так, команды плюс-минус такие же, типа данных плюс-минус такие же. Единственная парсия работает немножко иначе. То есть у нас нет там A to E и to A функции, а у нас есть данных, точка парси, потом мы записываем аргумент, то, что мы хотим сверить. По большей части, ну, мы ООП же проходили, уже в писали классы, да, даже. Здесь точно такой же подход. Все по классам только работает. Вот. Скажем, ну, дерево, как его сделать? Мы делаем основной элемент. Это вот переменная. Просто мы можем вот каждый блок рассмотреть как элементы, да? Просто где-то какой будет листом другого элемента. Я советую посмотреть, может быть, то, что мы делали даже до того, что вчера происходило, мы как раз составляли деревья. То есть бальные деревья составляли. Я думаю, это надо посмотреть, и будет понятно, как он это составится. Но перед этим здесь необходимо, сделал пару минут назад, необходимо иметь текст, который мы анализируем, чтобы понять, сколько делать всего, и для каждого символа процедуральное прохождение текста. Первое надо. Потом мы идем циклично, ну, точнее, бесконечным циклом, и мы что делаем? Мы вначале сортируем массив по убывающим, потом два последних элемента комбинируем.
Да.
И итерация повторяется. Мы делаем до момента, когда у нас остается только один элемент на силе. То есть вот такая ситуация. Плюс, когда мы комбинируем, хорошо будет сохранить. Вот, например, что мы скомбинировали и во что мы превратились. Корень, корень, допустим, там левое, левое, правое. И у вас получится массив из таких. А потом из этого массива довольно легко можно составить дерево. И вот у нас получится то же самое, что мы видим здесь. А потом, проходя уже по дереву до каждого листа, можно вот этот путь составить. И вот получается вот такой словарик. И это, в общем-то, все, что в этом входит. Потом мы идем на село, и заменяем село на комбинацию нулей. Вот и вот весь метод. Главное, что очень хорошо работает. Вы можете посмотреть, там 10 целых, 10 байт, а у нас снизу не будет 3 байта. То есть компрессия, ну там, я не помню сейчас сколько, стоит, по-моему, 2 байта или 6 ну, компрессия в районе 75%. Но это там далеко используется очень часто в самых операторах. А Windows Launch, который следующий, он точно везде используется. Например, в самой ZIP.
Так вот, мы идем на переход.
Да, идите на перекур, конечно. Главное, приходите назад. Okay, guys, so looks like we have to take the break, right? So if you need a break, you can go for the break. Okay,
Też jeśli to stosunkowo dla ciebie, ale trzeba to wszystko złożyć.
Żeby wystawiona. Nasz system czeka na wysoki świetla. Po prostu rozmawiamy z pomysłem na
Well, I suppose 10 minutes of the break are gone, right? Looks like.
Probably, yes.
All right. All right. So what we're doing at this point? Okay, you're trying the regex, right? Okay. You're trying regex as well, right? Ребята, как что вы сейчас делаете?
To сейчас будет продолжать.
Ага, так, так, что делаете? Ну, вы можете хотя бы попробовать реgex сделать регулярные выражения. Ну, это там отдельная тема у нас, реgex, чуть ниже будет. 11-12 интеграл. Да. Там есть примеры набора, как можно сделать. Ну, реgex, я думаю, известно, что такое, да? Потому что ОП распроходили, значит, что-то слышали. Вот. Ну, тут некоторые правила расписаны, они, правда, тут не все. Вот. Ниже будут примеры задач и выполнения их. Вы можете брать Java-коды и их, скажем, записывать в проекцию и пробовать выполнять эти задания, используя те выражения, которые даны как ответы. Ну, во всяком случае, потренироваться можете. Regex используется везде. Ну, начиная с проверки ввели ему почту. Так, ну, у вас уже штука готова, можете показать? Ну, покажите. на каком уровне у нас там что-то сделано?
Ну, я нашел немного кода и хочу его немного переделать.
Ну, окей, хорошо, хорошо. Пробуйте. И тут остается попробовать пытаться. Опять же, если это там алгоритм сложен, вы всегда можете попробовать сначала следующий сделать. Потому что тот, ну, куда проще, чем этот. Хотя, что здесь мы работаем с текстами, что там работаем с текстами.
Ну, да.
Right, so if you will need any help, tell me, okay?
Yes. I can try that.
You try them all, right?
Yeah, I need to speak.
Uh-huh. Okay. Then you can take a look on advanced ones. Oh, the only there might be that No, you know those are the examples. They're written in Python, but if you like, you can always take a look on those say on those patterns. Actually, this is the good document because, anyways, if you are familiar with Python, you can always copy these full solutions as well, if you like. Okay, so anyways, besides this one, what do we have for today? The next thing I was planning to have a small coding based on timing, and not really maybe on timing, but on the classes implementation related to such thing as called rule-like tasks. I suppose you know what's the story about. Something like, okay, maybe you know that computer game called Dwarf Fortress.
Dwarf?
Yeah.
I know.
Yeah.
Mm-hmm.
So you know we can always make something pixelized. Well, I can say why we are starting this one. Because afterwards, when we will get a bit of the Java effects, I will show you one of my presentations related to an NPC logic creation, where we have, well, primary descriptions of neural networks on the example for relationships. It's a good one, actually. You will like this presentation. We will have one. And then we will get how is it possible to make to get something. We have to know, we have to see some examples from real life. Actually, that will be the most simple to get. Actually, it will not be the first time I show exactly this presentation. Not the first time. Once I was asked to show exactly this presentation to run these classes at Vilnius University. University. So it's not blah 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 stuff. And in the end, we can make agents based on parameters of locations, and we can use a small neural network. And we'll have a talk about neural networks a bit. And the chromosome as the previous generation knowledge. And we will have the application. It's kind of combination of what you can find out on GitHub plus additions. And okay, we cannot run that jar files somehow. I'm a bit surprised, but we can, for example, extract this, and we can open that at least in IntelliJ. I can show you what's the story about downloads, where we have it. Yes, this one. Trust the project. Okay, let me do this window. Okay, let's start with the main one. Agent, yeah, things are shown here. That's great. Okay, Gradle is working. So yeah, we will have to wait a bit. Yeah, so something's downloading. Oh, that's kind of weird. Why do we have errors? Okay, yes, download the Amazon character. Yes, exactly. Another SDK. Yes. Yeah. Well, we would need to build that, but let's go for the running. Why we cannot really run that? Okay, maybe I will go through the main then. So NPCs hunting for the food. We can evolve generations. Good thing, right? And the main thing, this is really the generation knowledge being evolved here. Yeah. But again, before we start working with such things, we have to maybe work a bit on ASCII level, I mean on the symbolic level, to try this stuff. And then we'll need to get how visuals work in Java, and then we can start producing such applications, which is much better than the console stuff. So that's what it is. Yeah, good looking, right? Okay. Yeah. So before that, maybe you can try to implement the timing infinite loop with a sort of the update functions for the locations of elements, and you have some moving agents around, and you have some roles in which for sure agents cannot go inside, right? Literally, if you like, you can organize randomized direction selection, and then you can run the codes. Surely we can make an influence on all this, implementing a couple of different entities. For example, I don't know, predators who would be hunting around. So as you understand, if the cell where they stand is the same as this guy's cell, then the predator ate that guy, right? So it might happen. It will not be very maybe easy to imagine this implementation from the beginning, but try to think of that every entity has a possibility to be moved, right? And you can literally inherit these opportunities for every subclass. Okay, you can start with maybe a bit simplified case, right? Where you have, for example, and it's not necessary to use exactly this type of field. You can randomize one if you like. You can have random locations of all of those entities from the beginning. They could be moving. They could be some, I don't know, some plants to be eaten by those swans. I really hope it doesn't look complicated.
It doesn't look how it will go to look, I don't know.
Okay, it might happen that I can help you with that. So you will have some magic, right? You'll have position, isn't it? Okay, it will be integer, right? If you have the matrix. So you can have, for example, the movement, which would be somehow organized, maybe a step in randomized direction, where they can go. And in the main function, in the main class, you will have, for example, this one. You will have the infinite loop, in which, for example, you can have some time and some delay, and you literally, and what you can do, you literally can go through all of entities, and you can execute move function, and then you draw the net on the terminal, like we did with the robot and the grid. So you can imagine that you have a couple of robots in the grid. Okay, here we have some visual stuff, so that's why we don't need to maybe analyze a lot of these things. Now, this is the most correct one. For example, the time step, right? We go to agents, as you understand, right? And what we do? Well, we can run interaction. Okay, here we have the abstract class. In the same time, we can avoid moving. Well, here you can just organize moving. That's it. Apply new x, y position, or you can just run move function. That's it. Literally here we have the same, but only with floats in coordinates and with the visual graphics. I suppose logic is clear, right?
Yes.
If you don't know what you can start with, it's the array, right? It's the randomizer of elements on it, different symbols, different objects, and the agent class, where you have position and the function move. Then making the array of agents, then printing out, then looking, printing out the grid, and then modifying x, y, and move function. Is there anything else unclear?
For this moment, all clear.
theoretically. But you can try. Well, believe it or not, but when you will make this, it will be interesting because you will find out a lot of ideas what you can add there.
So you need to make it with
Just imagine you will like it, and afterwards you will make your own Dwarf Fortress. Why not?
do свинкос tai nestokime. Ir toks garsas, žinai,
Nes 4-5 eurų, tai jie skamba kitaip jau.
jo, ten gerai. Atbeisis. Reikia grafikų. Reikia grafikus. Priklauso, kada baigsis išleis. Space.
Guys, unfortunately, I will have to now be connected to one session. So so we'll be working kind of in the parallel. But I will be just evaluating presentation. So yeah, so I will definitely talk something to them. So it won't be for you, right? But anyways, you can surely ask when you will have questions, right? So you mentioned the word, right?
I quoted some quote from Bakshiti.
Well, good idea. Yes, good idea.
So I just button is like basic playground, so you
Makes
can
sense.
make like what it means, I guess.
Yes, sure. Yes. Whales.
So you need to understand how everything will work.
Oh, that's not your project, right?
Yes.
Okay.
I mean, I'm just using some code
Mhm.
to just start and understand what to do next.
Okay. Okay. Looks great. So we don't have any questions. Okay. How are you? What can you do? The one like. Так, ну как у нас?
Так.
Где по Саммерсу?
Ну, пришло увидеть.
Какую еще сделали все, что предполагалось, да? Это было хуже еще, обязательно. Ну хорошо, ладно, может быть другой метод. В любом случае,
Я не использовал в плане вывод как бы всех вот этих элементов. Я просто сразу писал. Не, просто у меня была проблема еще с этим, с 0,.
Погодите, ну как вы так можете делать? У вас int от 0, что-то, это ж 0 будет. У вас, буквально говоря, инты от всех этих значений будут нули.
Ну это вроде что-то было. Ну, в плане, ну, чтобы оно
Стоп.
было.
У нас с вами был C++ курс.
Ну, это было.
Это флоу не там был.
Вот. Да.
Извините, я должен помнить.
Вот. Вот.
Да, правильно. У вас больше
Это
ничего
можно
не-
раз.
А у вас больше ничего не смешает здесь. Ну, молодец, вы правильно написали, потому что есть мобильную дату написать, потому что это идти, с точки зрения, ну, с точки по умолчанию, мы можем написать. Но у вас больше ничего не смешает? Может быть, и значит,
Меньше вашего решения.
нет, ну что у вас здесь? У вас там пассив.
А,
Ну, конечно. Ну, я говорю, вы могли заняться третьим этим алгоритмом. А прессу гораздо проще. Ну, ладно, окей, как хотите. Потому что если будете задать вопросы, так, извините, там уже у меня это самое... Jā, sveiki, Kaspar. Tā, dzirdam mani? Tā, nu es padalījos ar saiti, tu vari paskatīties arī Moodle. Nu es katram gadiem varbūt pārkopēšu share invite, tad viņam... Nē, viss būs kārtībā, jau pirmais pieslēdzis. Mums vajag viņu pagarināt, ja? Ok, nu tad uzreiz tad prasam, lai viņi tad darbotos. Okay, so I see that Rajat and Newman are connected. Okay, so who will be the first one showing the presentation? Maybe we can start with Rajat. Okay, so share your screen, turn on your camera, and go on. Because by the rules, camera should be on, so we could see that exactly you're presenting. Yeah, so stages, you will share the screen and show the presentation and demonstration afterwards. Yes, we see the screen, so go on, start the presentation, please.
Да. Ну, дом там будет. Это действительно.
Выходит что-то новое. Уже. Ну, надо закодироваться, кодироваться. Хорошо. Текст. Это сообщение, это просто клип, как текст. something happens, right?
Some of them are moving, but
Listen, okay, and they eat those kind of grass, right? As I see some of cells energy.
yeah, they're moving.
Uh-huh. Okay. Looks really cool. Looks really cool. Может, такой прикол сделать. Смотрите, люди попали, ходили, и показывали. Посмотри, что правильно, но получается.
To je wyszczerta, po polski,
Happening something? No? А also more than your research?
Yeah, heavy talk what components which is working. But I need to make yes, that's not working. Да, и вот защита есть так, что
Okay, guys, looks like it's the break time, right? At least I have seen in the timetable.
same formula?
Okay, Rajat, so that's all from your side, right? Okay, will be there any demonstration? Mhm. Okay, so what's going on there? Someone is talking. Looks like next year, isn't it? No, the thing is that you have to know, because even you were talking not really to be ensure that well, what you were talking about. So another question is about the OpenStack. So what exactly did you install, OpenStack or DevStack? So what exactly was it? OpenStack implementation or DevStack implementation? And definitely the remark from my side, when you have a defense or presentation, don't make everyone think that you are lying on the sofa holding the laptop, because it's not polite to do that. And I was hearing some similar phrases as you were talking on the background. So maybe you can comment that somehow. Is there anyone who will tell you what you have to tell? Is there anyone around you who will help you with the presentation? It's not the answer for the question I asked. No, I asked about other things. But okay, anyways, I think my thoughts are correct. Okay, so you cannot demonstrate. The presentation is everything you can show. So that's it, right? So that's all you can show us, right? Okay, thank you. Thank you. So, yeah. So, who would be the next one? Probably since Nguyen was another person who was connected with Rajat. So maybe Nguyen, you can start your presentation. Yes, we can. Yes. Yes, we can see you. So please share your screen um, and show the presentation, please. Not yet. Yes, still we don't see your screen. There is the button next to the microphone, and it's written share on it. There's a rectangle with the arrow up. Well, on my side it's the same. Even I use the web version. No, we don't see.
Я neuzračuju po šitų, nu, kaip pasaulio tokį, nu, kaip turėtų atrodyti, kad tiesiog, kad visų generų. Tai yra žymiai tai problema.
Well, we don't. Okay, let's do it that way. So the next will be Clemens in this case. So Clemens, the stage is yours. Please show the presentation. Okay, then maybe Chamali. So maybe Chamali can show the presentation. Okay. Yes, we can hear you. So please share your screen. Open the camera as it's needed by the rules of University for Defense. Well, we don't see you and we don't see your screen. Okay. Oh, okay, we see you. Yeah, and your screen. Yes, thank you. So stage is yours. So please show us what you have.
Okay.
What's about the balance? Oh, it looks like you could have some screws, valves, some I don't know, mount,
Yeah,
some.
like that.
Yeah, like there.
Yeah, I'm thinking of doing these kinds of emojis.
That's what you're doing, you can continue this. Что у нас?
Уже я понял.
Я понял, TikTok у нас, да.
Лайки.
Да.
Ну, тогда немножко же трудно.
Вы же можете принтовать шаг за шагом и поменять настроение, все это придумать. Не забывайте, что можете распечатать на занимать. И вот таким образом выводить свои ошибки. Ну, система команд, ритовые, компи, например. Ну, видите, нации прошли, вот видите, что случилось. Сразу посмотрим, очень правильно. Shamali, are you about to show the demonstration sample? Okay, okay, we're waiting.
Yes.
So you're trying to know.
Дальше будут. Может быть, сайт.
Окей, хорошо.
Особливо, як буде та банки включають international, pasiekė limitą, kiek gali sudaryti automobilių žmonių, tai tada pasiekė žingsnį. Tada apie jie atsiranda. Bet tada pakankamai žmonių gyvena, jie pastatė tą našą ir tą mašiną prieš tas našą. Tai gana žygiai.
Ja. Gal tūlė jos front. Jos. VZV. VZV. Pakankamai. VZV čia yra.
Kažkiek žaliauti tas savo suprantu, bet tiesiog toks pasaulio lygis tiesiog kažką. Tiesiog pasaulio.
Yes, yes, we can see, and we have seen some plotters moving on. Yes, we see changes. Yes, the plot is moving. Yes, we do see it. Mhm. Okay, what kind of clouded system did you install? I mean, what kind of clouded system did you install for this project? As you remember from the term project rules, right? I mean definition, you have to have the clouded system, right? Was it like that? Because the name of the term project is the term project in a clouded system, in development of cloud computing systems, right? So that's why I'm asking which type of cloud computer system did you install? Mhm. Okay, because I was checking the document you uploaded, and yes, that's why I have these questions, because this main thing is not really fulfilled. Um, but okay, let's put it on the discussion then. So is that everything from your side? Is that everything you would like to show and demonstrate? Mm-hmm. Mm-hmm. Okay, thank you. Thank you. So you can disable the screen share and you can switch off the camera, and I will ask another student to run the presentation. Thank you. Okay, so it might happen that the next one. Oh, by the way, Nguyen, did you find out the solution? Okay, please try it. Yes, we see a screen, so stage is yours. So please show the presentation and then demonstration.
Our animals a priority. I know it's in the task of animals.
Okay, that's up to you. You can use whatever you like. But they have to be moving, right? Yeah. Cars, fish, ducks, no matter. What are you doing? What are you doing? What are you doing?
This is short right now. And he's trying to help me out with the start, well, step by step, the start code.
Okay.
I have to find out the code myself. See?
Yes, yes.
And if everything, it's the magazine. It's for the start because,
Does it help you?
yes, because I don't really know where to start off with. So I should just write, set up the project first, and I have to build a game program.
Okay. Yeah, great.
Galiu tiesiog plius, tai tenka. Tiesiog plius skirtingus. Vienas. Aš čia veikiu. Ką nori padaryti?
Okay, thank you. Newman. Demonstration is really good. Though it's better no presentation, which would summarize all of this. But anyways, it's fine. Scrolling the document, I didn't find the codes. Okay, there were installations, but unfortunately no codes for these charts. Maybe I have searched it better. Maybe it was there. I don't know. Oh, okay. Yeah, okay. So I will really like to see that. So you say there is the GitHub link, right? Okay, I will definitely check it. Okay, but all the rest it's fine. It's really cool. So I see the demonstration is really nice. Thank you. So again, what type of what version of DevStack did you use? Okay, thank you. Were there any issues during installation? Were there any problems during installation? Okay. So looks like that was it, right? Okay, thank you. Everything is clear from your side. Okay, so you can disable the screen share, you can disable the camera, and I will ask Pramadaja what will be the next one. Yes, go on, share your screen, show the presentation. Yes, we can. Don't forget about the camera because the roof of university. Yes, we can see you. Please start the presentation.
Можливо, смак транспорту.
Петролузна. Такой лайна стильно пролузена. Свадьбы.
Well, for Nadezhda, we see only the first slide of the presentation about the project. That's it. You have to share the full screen, not the particular window. So I'm just controlling them. Because I get to be the kind of the main of the comics.
Live, what's the title?
Okay, so what do we have?
Okay, she's on. Live attacker was lost.
Cool. And what's about movements? Kind of there's stuff on these lists.
I don't know by his start, but I make like AI. I just okay. I remember. We can move to the exhausted with the energy.
Okay. Looks great. Looks really great.
So I just involve some obstacles.
So you see, as I said, once you start to get ideas,
Yeah.
well, where monkey? Where is the banana?
Try.
Okay, what are we doing this? Okay, I see. Alright, looking on this. Ладно, как тест. Ну что,
Думаю.
давай просто сыграем.
Что?
Да, давай вопрос.
Сейчас будет комплекс создать.
Oh well, okay, because you were disappeared and I was just wondering what's going on. Oh well, Oh, wait a bit. So looks like Pramadaja just disappeared, right? In the middle presentation. Okay. Then maybe Clemens, maybe you can show what you have. Okay, thank you. So maybe you can share some information about um, the version of OpenStack you used? But you definitely download that by yourself, so you have to know it. Okay, maybe you can name the name of the version, the title of the version, like Newton, Pike, and others. Probably you have to remember that name. Mm-hmm. Okay, okay, thank you. Were there any issues during installation? Because Pike version is pretty old one. Mm-hmm. What's about Python libraries? So close to the latest. Mhm. Okay, that's a bit strange because I was expecting a bit different. But okay, if it is, then it is. I'm telling, if it is so, then it is so. Yeah. Because I was expecting that anyways, some problems could appear. Okay, things are clear. That's all from my side. Maybe Kaspers will have some questions. Okay, if that's all, so looks like we don't have questions to Clemens. Thank you. You can switch off camera and screen sharing. And since Permadaji is connected back, so we can ask Permadaji to continue his presentation and demonstration. And also about you in progress. Yeah, but maybe you can find out some examples, you know. Like the friends did. So they found some shipbuilding. Yeah, like I see that.
Tylko banana jest ładnie.
No farms. This should be a variable. So we're going through all things through all elements of this theory. Each element is being used and each element will be used of the type of the animal and will be written into animal variable. Like what it means. And the same like if you use a beach for each for each command. It's like for each all of the elements of the animals by the type of the animal, and each record will be each item will be written into animal variable. That's how that works. Okay, so Pramadaji, is that so? Okay. Kaspar, you had some questions, right? You were about to ask something. Pramadaji, do you understand what you just said? Because you wrote one thing and you demonstrate another things. So the question, how these things are connected, how the demonstration is connected to a paper which is submitted. Just imagine how it looks from a side. No, the thing is that you could write about the things you can demonstrate. So if you practically can work on Amazon cloud system and maybe plus something else, so it would be practically correct if you would even write about those things. Then we with Caspers, we wouldn't have this question. Sorry, I'm on the SIM card internet. So the thing is that if can you hear me? Okay. So if you would write about the things which you demonstrate to us, then we wouldn't have such questions, and it wouldn't be looking such a bit strange. I hope you understand this. Because in the paper you could write about anything you would like. Okay. Okay. Is there anything else from your side? Was what you expected to show us today? Mhm. Okay. Thank you. All right. So looks like everyone showed the presentation, right? If I'm not mistaken. Mm-hmm. Okay. Then probably we will ask you guys, you students, to be disconnected for some. Casper, probably we will need some maybe 15 minutes for discussion, right? Okay. So we with Caspers we will need 15 minutes for discussion. So after 15 minutes, students, please connect again to this session. And now you have to be disconnected because we will discuss first. We will discuss about your marks and if your works are passing the threshold, the marking threshold. So you just did that, right? Mm-hmm. Okay. Okay. I suppose we can take that into account, right, Casper? Mm-hmm. Okay. So students, yes. If no other questions, then please disconnect for 15 minutes. Tā, nu, liekas, ka viņi ir atslēgti. Tā, nu labi, nu ko tad daram ar viņiem? Ņūjenam. Nu, es viņam ieliktu, nu vispār viņam prezentācijas nav šodien, bet vispārējais ir, un demonstrācijas ir perfektas īstenībā. Es nezinu, kā tev liekas, bet es viņam droši ieliktu 9. Prezentācijas nav, nu diemžēl. Ok, tad Klemenam un... Es teiktu tā, tur ir stabils 8. Es teiktu tā, viss ir izdarīts, pie reizes telefons ir izmantots kā sensors, un bija live demonstrācija. Tas nozīmē, ka viss ir, bet, es nezinu, protams, mēs varam ielikt arī 9 balles arī starp citu, jo es vārstu starp 8 un 9. Ok, labi. Vienīgais, zini, dokumentācija nedaudz sliktāk uzrakstīta, jo zini, labi, čamalī tad 8 iedosim. Ojojojoj, tur ir sarežģīta. Tur es nezinu, gan dokumentācija ir pilnīgs hauss, un vispār, man īpaši patika. Tas, ko es biju redzējis. Ma- Jā. Man liekas, nesakrīt kaut kas. Nē, zini, man ir iPods pieslēgts. Un es diezgan labi dzirdu to, site sounds. Un man liekas, ka tur kāds stāv un pasaka viņam, ko jārunā. Man ir tāda iekšēja sajūta, ka es to biju sadzirdējis korekti. Man te vienkārši studenti vārka. Jā, protams, es gan nezinu, kā tu novērtāt maksimums uz 4 balām, bet vispār arī tādā attieksme pret, aizturēšu no tā guļot. Pagaidi tūliņas, jo viņi visi burtiski tā, ja viņi burtiski bija augšu pielādēti vai nu šodien, vai nu rīt vakarā. Mēs to nesalīdzināsim. Tūliņas. Nē. Tur pramadādžam vispār dokumentācija sastāv no 16 lapām. Nē, tur ir krietni vairāk ar screenshotiem. Tur ir 45 lapas.
You are currently the only person in this conference.
Tūliņas. Jā, redzam. Tā, un šī. Tūliņas es paņemšu. Tā, pagaidi nedaudz. Okay, guys, so anyways, we're finishing, right?
Yeah.
As we talked yesterday, so we're finishing maximum at 1:30. Yeah. So, okay, so anyways, tomorrow we have classes at 9, as you remember, online. Okay, bye-bye. Tā, kas par man vienkārši te studenti paralēli darbojas, bet viņi pabeidza jau. Tā, tūlņas es salīdzināšu. Tā, tabulu tad vienīgais es varu salīdzināt. It offers a highly flexible. Pieņemsim kaut ko. Jā. Kā es to nepamanīju, nezinu. Nulles liksim. Zini, viņi, protams, var pateikt, ka mums vienkārši liekas, ka tas ir viens un tas pats viņam. Nē, es tam neredzu, ka tas būtu rakstīts. Tas Šmits. Par Madāģim es neredzu, ka tas būtu rakstīts. Neredzu. Radžitam es biju redzējis, jā, Radžitam biju redzējis. Bakala darbs Alvis Šmits.